Yes, in this video, we are going to discuss about the application of linked list. So one of the famous application for linked list is polynomial representation using linked list. Okay. So let's see here how the polynomial can be represented. For example, if you consider a polynomial like this, 7x square plus 2x. So the same polynomial can be represented as here what is the value, that is number is 7. Okay, that is represented as part of the node in a linked list. So this node contains a total of 3 parts. The first part is num, the second part is coefficient, and the third part is a pointer which is pointing to similar node. Okay, so this should be num, and start pointer will be pointing to the starting node. Okay, and then what is the coefficient here? 2 is the coefficient, and next contains a pointer pointing to similar node. And if you observe this particular value, so again it is represented with the help of num, coefficient, and next. Okay, so what is the number here? 2 is the corresponding number. And what is the coefficient? So 1, right? Coefficient is 1. And next is the pointer. This particular pointer is pointing to null because there is no other part here. So it is clearly pointing to null, isn't it? Like this. So from this we can easily understand that struct node, this is going to create a node. Okay, and this particular node contains a total of 3 parts. So the first part is num, the second part is coefficient, and third part is next. So next is basically the pointer pointing to similar node. Okay, because this is of type struct node. So now let's analyze the code for creating a polynomial function. So this particular function is used to create a polynomial, and this is a start pointer which is pointing to the start of the entire linked list. And for this purpose we have taken new node pointer and ptr. So n is representing the number that you enter at runtime, and c is representing the coefficient that you enter at runtime. So using scanf statements we are reading the number and coefficient respectively here, and you need to iterate this block of statements until n value is not equal to -1. Okay, so a number that is entered is not equal to -1. Okay, till that point we are trying to read, okay, and allocate memory. So this is just to terminate the loop condition. Start double equal to null. So initially this start pointer will be pointing to null. Yes or no? Start is clearly pointing to null. Okay. So now new node is the pointer which is used to point to the newly created node. Yes or no? So you can observe new underscore node will be the newly created pointer pointing to new node. Okay, newly allocated node. So this node again contains the following parts like num, this is coefficient, and this is next. Okay, which is a pointer. So now let's see the initialization here. New node arrow num is equal to n. So which means this is basically initialized to n value. Okay, so let us suppose value of n is taken as 5. So n equal to 5, and consider c is equal to 2. In that case 5, 2, and next will be null, like this. Else, this else block represents start is not pointing to null. Yes or no? Start double equal to null is if condition. So if this condition is evaluated to false, then it will enter into the else block. So inside else block you can observe this represents start pointer is not actually pointing to null. It means there is already a node. Okay, let us suppose consider a node with data like this 5 2, and this is pointing to null. This is already existing. In that case, how we can perform is ptr arrow next not equal to null. So which means it will make ptr to point to this one. Ptr next not equal to null condition becomes false. Associated statement will not be executed. So now this is going to create a new node. Okay, new node pointer will be pointing to newly created node, and this newly created node contains again three parts. Okay, so this is number part, this is coefficient part, and this is a data, this is next part, isn't it? Okay, like this. Now you can see n value. Okay, so it's basically, let us suppose this time 3 is the number and coefficient is 1, and this is initialized to null. ptr arrow next equal to new node, which means this particular pointer will be pointing to new node. This is how a new node is basically added to the linked list. So this is completely representation of 5x square, okay, plus 3x, like this. So now this is the else block, and finally enter the number. N value is taken. The moment n value is -1, suppose you enter n value is -1, immediately break. This is going to break the loop. If n value is not -1, then that particular node will also be added after this. Okay, and finally the start pointer will be returned, because start pointer is always pointing to the start of the linked list. Next, how to display the entire polynomial. Okay, in order to display the polynomial, first since it is stored inside the linked list, we have to iterate through the entire linked list and display the elements. Okay, so consider this is a start pointer, and this start pointer is pointing to the first node, and it contains total of 3 parts. Okay, so this is num, this is coefficient, this is next. Okay, and this is another node, and it contains again 3 parts. Okay, so let us suppose this is 5 2, and this is a pointer pointing to this one. It contains 3 1, and this is pointing to null. Let us suppose this is the linked list that we have created. So again this is num, this is coefficient, and this is next pointer. Okay, so you can observe ptr is the pointer, ptr equal to start, which means ptr will be the pointer which is pointing to the start node. Now ptr not equal to null, as ptr is currently not pointing to null. In that case it is prompting you to display ptr arrow number and ptr arrow coefficient. Ptr arrow number is 5, ptr arrow coefficient is 2, and then ptr equal to ptr arrow next, which means ptr pointer will be pointing to the next node. In the next iteration, ptr not equal to null condition becomes true. Ptr arrow num, okay, ptr arrow num means 3 will be displayed. Okay, and then ptr arrow coefficient 1 will be displayed. Okay, so this time in the next iteration, ptr not equal to null, ptr is now moved to the next position, right? Because ptr equal to ptr arrow next, ptr will be now pointing to this null. So ptr not equal to null condition becomes false, block of statements will not be executed, and start pointer will be returned. So by the time you can see already this is completely displayed. Yes or no? So next, in order to add a node, we are considering this particular function, and in this function we are considering start pointer as a parameter, n is the number, for which a new node that you are trying to add, and C is the coefficient inside that particular node. Okay, so consider a scenario where start is already pointing to null. When start is already pointing to null, and now you want to add a new node. Okay, so how this new node is going to be added to this particular start pointer? And as we know, new node is a pointer which is pointing to the newly created node, and this newly created node has got total of three parts. First one is num, second one is coefficient, and the third one is next. Okay, let us suppose value of n given is 6. Okay, and the coefficient given is 3, and this is null, right? This is representing null. Now in order to add this particular node, okay, we want to add this node to the existing linked list, which is start pointer pointing to null. So it's very simple. We have to make sure that start pointer from now onwards is pointing to this new node. So then we can say this is the new node that is added, and you can see this newly added node is available here. Okay, and next in the else block, you can observe currently consider start pointer is pointing to some node. Let us suppose start is the pointer which is pointing to the already allocated node containing data like this 6, 3, and consider this is pointing to null. Okay, so now we want to add a new node, right? So we have to consider a new node pointer, and new node pointer is pointing to the newly created node containing the following things like this is number, this is coefficient, and this is next pointer, right? So new node arrow num is equal to n. So you can observe this is num part, this is coefficient part. Okay, so new node arrow num is equal to n means we are basically storing n value here. Let us suppose n value is 2 and coefficient value is also 2. Okay, and new node arrow next is initialized to null. Now ptr arrow next equal to new node. We know ptr is basically pointing to start. Okay, ptr is a pointer pointing to start, and ptr arrow next not equal to null. Ptr is arrow next not equal to null condition becomes false, hence the associated statement will not be executed. These two lines of code will be helpful in order to move this pointer called ptr to the end of the linked list. Once you move the ptr to the end of the linked list, it's easy to add the new node pointer to that one, right? So since it is already pointing to the end of the linked list, as the linked list contains only one node, so ptr arrow next must be pointing to new node. This ptr arrow next must be pointing to new node. So and finally you have to return start pointer back to the calling function. So this is how we can return the start pointer, and this is how we can perform addition operation on polynomials which are represented with the help of linked list. Okay, so yeah, this is basically adding a node. Okay, till now what we have seen is adding a node to the linked list. So next now we will perform adding a polynomial. Okay, so in order to add a polynomial, first you have to represent two polynomials. One polynomial is represented by start 1 pointer, and the other polynomial is represented by start 2 pointer. So let's consider in this case, so start 1 pointer, start 1 is the pointer which is pointing to, let us suppose 7, 2, and this is null. And similarly consider start 2 pointer. Start 2 pointer is pointing to 3, 2, null. Okay, so first we need to perform this summation operation. For that purpose we are taking sum underscore num. Okay, and now Consider ptr1 is equal to start1. So we are assuming ptr1 pointer pointing to start1 here. So ptr2 is equal to start2. ptr2 is another pointer which is pointing where start2 is pointing to. Next, ptr1 not equal to null, logical and ptr2 not equal to null. So ptr1 is not pointing to null, logical and ptr2 not pointing to null. Condition becomes true. Okay. So since this condition is true, ptr1 arrow coefficient double equal to ptr2 arrow coefficient. So you can observe this particular node containing three parts: num, this is coefficient part, and this is next part. Okay, so again in this is num, this is coefficient part, this is next part. Okay, so ptr1 arrow coefficient double equal to ptr2 arrow coefficient, which means 2 double equal to 2 condition becomes true. Hence we can perform addition operation on these polynomials, right? So sum num is equal to, now we can perform sum underscore num is equal to ptr1 arrow num. ptr1 arrow num is 7 and ptr2 arrow num is 3. 7 plus 3 is equal to 10. So next we have to add a new node, okay, with start3 as the pointer. Now we are creating a new linked list where start3 is the pointer pointing to newly created node. For that newly created node, we have to pass this newly obtained sum as the number and ptr1 arrow coefficient, which means this particular coefficient as a parameter. So then automatically it is going to build a new node which is having total of three parts. In the first part it is going to place sum underscore num which is 10, and in the second part it is going to place a coefficient which is 2, and the third part is basically null. Okay, so now we have to move this ptr1 equal to ptr1 arrow next. So in this case ptr1 will be pointing to the next. Basically this is pointing to null, right? So both are pointing to null, and here also ptr2 will be pointing to null. Okay, so in the next iteration, you can observe ptr1 not equal to null, logical and ptr2 not equal to null. Condition becomes false because both ptr1 is pointing to null and ptr2 is also pointing to null. Okay. So suppose if you consider ptr1 coefficient is different and ptr2 coefficient is different. Suppose this particular condition is becoming true. So let me consider an example for this. Start1 pointer is clearly pointing to a new node, and this particular node contains again three parts. So let us consider this is 7, 2 and this is null. Similarly, start2 is representation of another polynomial which is pointing to another one, like this is 3, consider this is 2 and this is null again. So if you observe, this is number, this is coefficient, so this is number, this is coefficient. Okay, so start3 is equal to, now okay, based on this you can observe ptr1 itself is a pointer pointing to this node, and ptr2 will be a pointer pointing to this node. ptr1 arrow coefficient, okay, let us suppose I'll consider this coefficient as 2 and this particular coefficient as 1 in this case. Okay, so ptr1 arrow coefficient, that is 2 greater than 1, condition becomes true. Now we need to create a new node, okay, and that node must be added according to add node function, and that should be returned to the start3 pointer, which means a start3 pointer is going to point to this newly created node, and in this newly created node we'll have a start3 comma ptr1 arrow num comma ptr1 arrow coefficient. So which is basically we have to place this 7 first, okay, and then 2, okay. So later we have to make this ptr1 to point to the next position. Like this clearly tells you whatever coefficient is greater, you have to keep that node first. Similarly, if the coefficient of the PTR1 pointer pointed by that particular node corresponding coefficient is less than the PTR2 pointed coefficient, in that case you have to create a new node, but this PTR2 should be placed first this time, because in this case we are considering PTR2, which is pointing to the coefficient, is larger. Okay, so in that case that comes first, and PTR2 must be pointing to the next node, like this. Okay, so what happens when the PTR1 is already pointing to null but PTR2 is not equal to null? So I'll show you a quick example here. PTR1 is a pointer which is already pointing to null, and consider PTR2 is not actually pointing to null, it is pointing to a node. For example, 5, 3, and like this. This is a 2, 1, and this is null. Okay. So start 3 is equal to add node. Using add node function, we are adding this particular node where PTR2 arrow num and PTR2 arrow coefficient. So this is number, this is coefficient. So is going to be added, right? So this is the case, and PTR2 will be pointing to the next pointer, right? Next node, because PTR2 is equal to PTR2 arrow next. So this is one case where PTR1 is pointing to null and PTR2 contains some content. In that case, you have to consider PTR2 content into consideration because PTR1 is already pointing to null. So the other way is PTR2 can be pointing to null. So I'll show you here. PTR1 is already pointing to some content, for example, like this. But PTR2 is currently pointing to null. Okay, so in this case we have to consider PTR1 because it has some data. PTR2 doesn't have any data, so we just need to add this particular node according to add node function. Okay, like this. And finally, once you create a start 3 pointer which is pointing to the newly added polynomial, so immediately return this start 3 pointer.